Hey everybody, we're going to take a look at 1D, conservation of momentum. So just as a review, we're going to go through hit and bounce scenarios, as well as hit and stick and explosion. So let's run through a few questions. I've got this first one here, a hit and bounce question, and I've set up some information like the diagram and the variables that I have and the variable that I want to solve for. So here we have a 12-gram ball that rolls on a frictionless surface with a velocity of 22 centimeters per second to the left. And it's important that we have these directions uh, indicated. And then you can see that I put the velocity as negative 22 centimeters per second. And the 12-gram ball bounces back, so in the other direction, at 10 centimeters per second. So I show that as positive 10. So you can see before the arrow is to the left and afterward the arrow is to the right. Now it says determine the velocity of the second ball after the collision that was initially at rest. So before it shows the velocity of 0, and afterward I just highlighted there the velocity that I need to solve for. So this is the hit and bounce as indicated, and we set up the equation by just going the sum of momentum initial equals the sum of momentum final. And we'll expand that out. So we'll say mass 1, velocity 1, plus mass 2, velocity 2, equals mass 1, velocity 1 prime, plus mass 2, velocity 2 prime. So the objects are independent before the collision and independent after the collision. And we can see that it is the velocity 2 after the collision that I need to solve for. So I'm just going to manipulate the equation for that velocity. So we'll go m1v1 plus m2v2 minus m1v1 prime and divide it by mass 2. So I want to substitute all of these values in here, and it's okay to leave things in grams and centimeters per second. So negative 22.0, and then I'll add that to mass 2, 22 grams, as long as we're keeping all of these uh, units consistent. Okay, that one should be the 0 velocity, and then mass 1 is 12 grams again, and this is the velocity after the collision, which is 10 centimeters per second. So I can see here that this term just cancels out. And then I divide it by mass 2, which is 22 grams. Kind of looks like 22.6. There we go. Same. 22 grams. Okay, so velocity 2 prime, which is ultimately what we want to solve for in this question, is, and we'll get our calculator, 12 times negative 22 minus 12 times 10 equals divided by 22, and I get 17.5, negative 17.5 centimeters per second. So the negative indicates that this velocity is in the left direction. Okay, so that's hit and bounce quite quickly. Let's go to hit and stick. And so I have a second problem here where the two objects collide, but they lock together. In this case, they're train cars that couple together. And I want to find the velocity of the cars after they lock together and the impact has occurred. So I have the two cars, one of 6,000 kilograms and one of 3,000 kilograms. And that's hit and stick. So I look at sum of momentum initially equals sum of momentum final, which means I have mass 1, velocity 1, plus mass 2, velocity 2, and they stick together. So I'll add them together and they have a combined velocity. It really doesn't matter what subscripts you're using, but I'm just using 1 and 2 there. So I want to solve for this final velocity. So I'll just manipulate the equation and divide by m1 plus m2. Okay, now let's put in these values here. So mass 1 is 6,000 kilograms. Oh, that's really bad. 6,000 kilograms times the velocity of positive 2 meters per second. And mass 2 is 3,000 kilograms, but it's at rest. And then we'll just add these two masses together and calculate the final velocity. So I find it works really well to separate this into mass times velocity because we have to find the momentum anyways. So let's go 6,000 times 2, and this is 0. So then I'll divide that by 9,000. So this should be positive 1.33, and I'm using the units of meters per second. 3 significant digits. Okay, and lastly, we'll take a look at an explosion question. So here we have a rifle that shoots a bullet, and so there is on the left initially, the box is representing the rifle with the bullet in it, and afterward, I have the rifle and the bullet separately. I can show here that the bullet is moving with this velocity, and then the recoil velocity would be in the opposite direction for the rifle. So I want to find the velocity, the recoil velocity of the rifle after the explosion. So let's start with the sum of momentum initially equals the sum of momentum final. Together I have a total mass, that's a T, a total mass times velocity equals the rifle and its velocity prime and the bullet and its velocity prime. Okay, these were at rest, so that's just 0, which means that if I'm trying to find velocity of the rifle, the recoil velocity, that will be equal to negative mBVB prime divided by mass of the rifle. Okay, let's substitute our values in. So the mass of the bullet looks like 0.0500 kilograms times 300 meters per second in the positive direction. And then the rifle is 5 kilograms. So the velocity of the rifle is 0.05 times 300 divided by 5. So this is negative 3.00, and my units were meters per second. So the rifle goes in the opposite direction at a much slower velocity because it's a greater mass. That way the momentum is conserved. Okay, hope that helps you out. Next step, two-dimensional collisions. See ya.